Welcome to this demo of Synthia, a Java library that can be used to generate synthetic data objects of various kinds. What kind of data can we generate with Synthia? The short answer is pretty much any Java object you like, provided that a generator exists for it. The core of Synthia provides generators, or pickers as they are called, for various common objects: numbers, booleans, character strings, lists, trees, graphs. If you cannot find a picker that suits your needs, you can also create your own. In the next few minutes, I will give examples of some of Synthia's features that make it stand out compared to other approaches. All these examples can be found online in the repository of code examples that comes with Synthia's API documentation. A first feature of Synthia is modularity. Its architecture is based on the notion of a picker, which is an object implementing a method called pick. Its task is to return an object of a given type every time it is asked. The interesting part is that pickers can be instantiated by other pickers and use them as a source of choice. Here we have a simple program that generates a list of two-dimensional points. The box at the bottom is a picker that generates points based on a circle radius and an angle. As you can see in the illustration, other pickers connect to this one and determine how this radius and angle are selected for every point. Here each is based on the generation of a random number. If I run this program, I get a list of points, and if I drew these points I would get plots like the ones seen at the bottom of the screen. If I change the way the picker is wired to other pickers upstream, I get other patterns of points, as you can see in this other example. Of course, producing points is relatively easy, but it shows how objects following complex patterns can be created by plugging or wiring pickers together in a different way. Just for fun, here's a piece of code where a chain of pickers simulates the operation of an AM radio, and here's another one that generates a random scale-free graph simulating a website map, and then interleaves multiple random walks in this graph to generate a fake web server log. Note how in each case the chain is instantiated at a high level of abstraction and contains relatively few lines of code. A second important feature of Synthia is its explainability. Every object produced by a chain of pickers, and even parts of an object, can be retraced to the precise upstream objects and values that contributed to its creation. Here's a code example where I create again a list of two-dimensional points in a different way. First, I instantiate the chain of pickers, and then I call pick to get a few lists. The interesting part is the last three lines. I designate a part of the first output list, namely its first element, and then ask Synthia to give me an explanation, which takes the form of a graph. This graph can then be rendered using GraphViz, for example, and produce a graph like the one shown here. This comes built in with Synthia, and as you can see, requires a single instruction, whatever complex the picker chain may be. A third feature is called input shrinking, similar to what can be done in implementations of the Quick Check framework. Here's an example where lists of integers are randomly generated until one is found that exhibits a fault in the underlying sorting algorithm. Pickers implementing an interface called shrinkable can automatically produce smaller values, and the repeated search for smaller and smaller values is automated by an object called assert. The way in which this shrinking proceeds is also special to Synthia, but to know why you'll have to read the paper. Here notice how a smaller example exhibiting the error is found after a first much larger instance has first triggered the fault. Synthia can also shrink sequences of actions sent to a reactive system. The sequence of actions is produced by generating random derivations of a grammar. This feature also comes built in. And once a failing sequence is found by another object called monkey, search for a smaller sequence proceeds automatically. Note that as with any shrinking in Synthia, the shrunk input preserves the properties of the original. Hence here, any smaller sequence that is being tried is a subsequence of the original that is still a valid derivation of the grammar and not just any subsequence. There are many other things one can do with Synthia, and 5 minutes is way too short to show them all. I encourage you to parse the code examples that are available online. To sum it up, the main interest of the library is of course what you can do with it, but almost as much how you do it. The core of the library is made of a handful of simple abstract interfaces, which makes the design very flexible and versatile. Thank you for listening.